Right now, forecasters across Europe are watching a setup develop that's serious enough to earn the highest risk category their outlook system actually has. Not an elevated risk, not a moderate risk, a high risk, the top tier reserved for events forecasters expect to be genuinely dangerous and genuinely widespread, and it's been placed directly over eastern and central France, western Switzerland, and southwestern Germany for today. Inside that zone, the specific threats being forecast include tornadoes rated as a high probability, hailstones larger than 8 centimeters across, capable of shattering windshields and punching through roofing, wind gusts reaching up to 120 kilometers an hour, and rainfall totals up to 100 millimeters within 24 hours, enough to trigger genuine flash flooding. And this isn't a one-day event that clears out and moves on. Tomorrow, that same violent weather system shifts east, carrying an equally serious risk into the Alps, Austria, the Czech Republic, and southwestern Poland. 2 consecutive days, an entire swath of Western and Central Europe, and a threat level meteorologists don't reach for casually. I want to walk you through exactly what's setting up over the coming 48 hours, exactly why the atmosphere over Europe is primed for something this violent right now, and exactly what to do if you live anywhere in the path of what's coming. Let's start with the official forecast itself, because the specifics matter here, and I want to walk through them with the same precision the meteorologists issuing this outlook used. Severe Weather Europe, one of the continent's dedicated severe weather forecasting services, issued a high risk designation, their most serious classification, for a 2-day severe weather outbreak, running from Thursday morning through Friday night this week. For Thursday specifically, that high risk zone covers east central France, western Switzerland, and southwestern Germany, with the forecast discussion specifically flagging a high probability of tornadoes, maximum hail size exceeding 8 centimeters, peak wind gusts up to 120 kilometers an hour, and 24-hour rainfall totals reaching 100 millimeters. Surrounding that high-risk core, a broader moderate and enhanced risk zone extends across most of France, Switzerland, northwest Italy, western Austria, southern, central, and western Germany, and the Benelux region, covering a threat for severe winds, large hail, and torrential rainfall across an even wider footprint, even if the most extreme, most concentrated activity is expected to stay within the tighter high-risk core. Then, on Friday, the entire system shifts eastward. The forecast discussion specifically describes storms merging into large clusters overnight. Thursday into Friday, as the system continues moving northeast into southwestern and central Germany, before a fresh round of severe thunderstorms fires up over the Alps during Friday afternoon. That second day carries a moderate risk designation for eastern Switzerland, Austria, the broader Alpine region, the Czech Republic, and southwestern Poland, with the same fundamental threats carrying over: severe damaging winds, very large to giant hail, torrential and excessive rainfall capable of producing flash floods, and tornadoes, this time assessed at a medium rather than high probability. An enhanced and slight risk zone surrounds that core as well, stretching into southeast France, northern Italy, western Slovakia, west central Poland, and eastern Germany. I want to walk through the actual meteorology driving this, because understanding the mechanism is exactly what separates a genuinely useful weather breakdown from just repeating a scary forecast without context. The setup driving this entire 2-day outbreak involves a large, deep upper level trough emerging into Western Europe, essentially a dip in the jet stream carrying cooler air and strong upper-level winds southward. Arriving at the same time, a strong blocking area of high pressure sits parked over the Mediterranean region. Between those two large-scale features, a powerful southwesterly jet stream develops, providing the kind of intense wind shear, meaning winds that change speed and direction significantly with altitude, that's essential for turning ordinary thunderstorms into organized, rotating supercells capable of producing large hail and tornadoes. At the same time, the air mass sitting beneath that jet stream is extremely humid, and that humidity is directly tied to something we've covered on this channel before: an extreme, ongoing Mediterranean heat wave that's been baking southern Europe for days. Powerful westerly winds aloft are actively pulling that high moisture, high dew point air out of the western Mediterranean and transporting it directly into southern and southeastern France. And forecasters specifically note that given the ongoing extreme heat driving those high dew points, the resulting atmospheric instability is reaching moderate to locally extreme levels, with a specific measurement called MLCP, which quantifies how much energy is available for a thunderstorm updraft, reaching somewhere between 2,000 and over 4,000 joules per kilogram across southeastern France. To put that number in context, values in that upper range are genuinely extreme, the kind of instability that supports the most violent, most dangerous storm modes rather than an ordinary summer thunderstorm. Combine that extreme instability with the intense wind shear provided by the jet stream, And you get exactly the kind of volatile atmospheric environment that produces explosive thunderstorm development. The forecast discussion specifically describes this beginning around midday Thursday, initiating over the Massif central region of France and spreading into the Rhone Valley, where southerly moist winds continue transporting high dew points northward, feeding the developing storms. Isolated but intense supercells are expected to be the dominant storm type as this activity gets going, exactly the kind of storm structure capable of producing large to very large hail, damaging winds, and torrential rainfall all from the same individual storm cell. And the tornado threat specifically is described as maximized across the Rhone Valley portion of the high-risk area in southeast France, where the highest storm relative helicity and low-level wind shear, both specific measurements meteorologists use to assess a storm's rotational potential, are expected to be present. As the afternoon progresses into evening, these storms are expected to move quickly east-northeast, spreading toward western Switzerland and southwestern Germany. Through Thursday night, the forecast describes these individual storms merging into one or more large clusters as they continue pushing northeast into southwestern and central Germany, with large wind-driven hail, severe damaging winds, and torrential rainfall remaining the primary threats as that merger happens. A separate area of enhanced storm activity is also expected to develop to the north, moving toward the Benelux region and western Germany during the late afternoon into evening, bringing widespread storm activity as those systems cluster together as well, with severe winds and torrential rainfall as the main threat, alongside a real tornado potential in that zone too. And in a detail worth flagging specifically, if you're anywhere in the UK, isolated severe storms are also possible across southern England, near where the broader wave crosses during peak afternoon heating, supported by moderate instability and relatively strong wind shear in that specific area. Friday's evolution of this same system carries the threat into an entirely different set of countries. Isolated thunderstorms are expected to initiate over the Alps during the early afternoon, supported by moderately strong instability and amplified wind shear continuing from the day before. Intense multicell storms and supercells are expected to be the primary storm mode initially, before that activity clusters into one or two large convective systems as evening approaches. And here's a detail worth understanding, because it illustrates exactly the kind of genuine, honest uncertainty that exists even within a high-risk forecast like this one. The forecast discussion specifically flags real uncertainty about exactly how intense and how large the resulting mesoscale convective system, essentially a large organized cluster of thunderstorms acting as a single system, will actually become as it moves from southeastern Germany and northeastern Austria into the southwestern Czech Republic. Some high-resolution weather models are specifically hinting at violent wind gust potential from bowing segments, a specific storm structure where a line of thunderstorms bows outward under intense internal winds, forming off the supercells that developed earlier in the day. If that specific scenario plays out, destructive winds could exceed 120 kilometers an hour, producing widespread severe wind damage across the moderate risk area and continuing to spread northeast into southwestern Poland overnight. I think it's worth pausing here to explain exactly why a high-risk designation matters so much within European severe weather forecasting specifically, because it's not a category forecasters reach for on a routine basis. Severe weather outlook systems across Europe, much like their counterpart used by the Storm Prediction Center in the United States, use a tiered risk system specifically designed to communicate how confident forecasters are that genuinely dangerous, high-impact severe weather will actually occur, escalating from a general thunderstorm mention up through slight, enhanced, moderate, and finally high-risk categories. A high-risk designation represents forecasters' highest level of confidence that a specific region is about to experience a genuinely significant, potentially widespread severe weather outbreak, the kind of event capable of producing multiple tornadoes, giant hail, and severe wind damage across a broad area rather than an isolated, localized storm or two. Days carrying this specific designation are relatively rare across an entire severe weather season, which is exactly why meteorologists across the continent have been treating this specific 48-hour window with the level of seriousness reflected in every detail we've just walked through. Now I want to widen the lens beyond just this specific 48-hour severe weather outbreak, because it isn't happening in isolation, and understanding the broader pattern it's emerging from helps explain why the atmosphere over Europe is primed for something this volatile right now. The severe weather outbreak is directly connected to an extreme ongoing Mediterranean heat wave that's already been making headlines across the continent. Just days before this severe weather threat developed, forecasters were tracking yet another heat dome expanding across south-central Europe, described as the sixth major heat wave of the season, pushing temperatures above 40 degrees Celsius across Italy and the Balkans. That heat event has been producing genuinely brutal conditions, with peak afternoon temperatures across low-lying river basins and plains ranging from 38 to 43 degrees Celsius, and critically, minimal overnight relief, with low temperatures refusing to drop below 22 to 26 degrees Celsius across major urban corridors. That lack of nighttime cooling compounds severe physiological stress on millions of residents, significantly increases energy grid demand as air conditioning use spikes and heightens explosive wildfire conditions across valleys throughout southern and central Europe. It's precisely that same extreme heat and the moisture it's been pulling northward that's now feeding directly into the severe weather outbreak we've spent this entire video walking through, the connective tissue between one major weather story and the next. And this entire stretch of extreme weather isn't an isolated summer either. Europe has faced a genuinely difficult year on the heat front throughout 2026. Back in late May, an unusually early and severe heat wave broke temperature records across Spain, the United Kingdom, Germany, France, and Ireland, with Portugal specifically recording a peak temperature of 40.3 degrees Celsius at a location called Mora, and London, recording temperatures inside underground trains and stations reaching over 34 degrees Celsius. That single event was directly tied to 11 deaths. And for a sense of just how serious extreme heat can become across this continent when conditions turn genuinely severe, a major peer-reviewed study published in the journal Nature Medicine found that the summer of 2024 alone produced more than 62,700 heat-related deaths across Europe. A genuinely staggering toll that underscores exactly why meteorologists and public health officials across the continent treat every subsequent heat wave with real seriousness, rather than dismissing it as simply an uncomfortable stretch of hot days. There's a broader seasonal context worth understanding too, because this specific outbreak is unfolding during what's already shaping up to be a genuinely active period for severe weather across Europe more broadly. The 2025 to 2026 European windstorm season, the coordinated naming program several national weather services across the continent use to track and communicate about significant storm systems, has already produced 39 separate named storms and more than 487 fatalities as of the most recent count, with the strongest storm of the season, Storm Joseph, reaching a central pressure of 939 hectopascals and the strongest single wind gust recorded during the season, associated with Storm Amy, reaching 139 miles an hour at a location in Norway. That's the broader backdrop this specific 48-hour severe weather outbreak is landing on top of, a season that's already been producing genuinely significant, sometimes deadly storm activity well before this particular event even developed. I also want to mention something worth understanding for the months still ahead, because forecasters tracking Europe's broader seasonal pattern have specifically tied the coming winter to the exact same underlying driver we've covered extensively elsewhere. Long-range forecasters have already issued their first outlook for the winter of 2026 into 2027, specifically describing it as shaped by a super El Niño currently developing across the Pacific Ocean, an event that's already produced the highest reading on the primary scientific index used to measure its strength since that measurement began being tracked in 1979. That same event is expected to drive a major weather divide across Europe this coming winter, similar in structure to the split flow pattern we've discussed shaping North America's winter forecast, meaning the severe weather and extreme heat Europe has been experiencing. This summer may well be a preview of a winter season that carries its own significant, still developing complications once the calendar turns. Let's talk about what you should actually do if you live anywhere within the path of this specific outbreak, because a forecast this detailed and this serious deserves genuinely practical guidance rather than just abstract concern. If you live anywhere across East Central France, Western Switzerland, or Southwestern Germany, today is a day to take real active precautions, rather than simply noting the forecast and moving on with your normal routine. Bring in or secure any loose outdoor objects, garden furniture, umbrellas, anything that hailstones exceeding 8 centimeters or wind gusts approaching 120 kilometers an hour could turn into a genuine projectile. If you have a vehicle, you can move under covered parking. Do it now, because hail of the size being forecast today is fully capable of shattering windshields and severely denting or destroying an exposed car. Know where your safest sheltering location actually is, ideally an interior room on the lowest available floor, away from windows, and have a way to receive warnings that doesn't depend on you actively checking a forecast throughout the day, because these storms are expected to develop and intensify quickly once they get going this afternoon. If you're anywhere near the Rhone Valley specifically, understand that this is the zone where forecasters have specifically flagged the highest tornado potential within today's entire outbreak, and treat any Tornado warning issued for your specific area with immediate serious action rather than waiting to see the storm yourself before taking shelter. If you live anywhere across the Alps, Austria, the Czech Republic, or southwestern Poland, today's forecast is your early warning for tomorrow, Friday, when the same system's threat shifts directly into your region. Use today to make the same preparations, securing loose outdoor items, identifying your safe shelter location, and making sure you have a reliable way to receive warnings, so you're not scrambling to prepare once storms are already developing over the Alps tomorrow afternoon. And regardless of which specific day or country you're in, the flash flood risk tied to this system deserves the same seriousness as the wind and hail threats. Rainfall totals reaching 100 millimeters within 24 hours can overwhelm drainage systems quickly, particularly in urban areas and anywhere near smaller streams and rivers that respond fast to intense rainfall. Never attempt to drive or walk through flooded roadways, because it takes surprisingly little moving water to sweep a vehicle off the road or knock a person off their feet. And standing water on a road at night is often impossible to judge for depth until it's too late. I want to spend a moment on hail specifically, because I think it's genuinely one of the most underestimated hazards within a forecast like this one, precisely because it doesn't carry the same immediate visceral fear that a tornado warning does. Hailstones exceeding 8 centimeters across, roughly the size of a large orange or a small grapefruit, fall with enough force to cause serious, potentially life-threatening injury to anyone caught outside without adequate shelter, and they're fully capable of punching through standard roofing material, shattering skylights, and destroying vehicles left exposed. If you hear a severe thunderstorm warning specifically mentioning large or giant hail getting under solid, substantial shelter matters just as much as it does for a tornado warning. And standing near a window to watch hail fall, however tempting that might be, genuinely isn't safe when stones of this size are involved. Let's talk about the broader forecasting lesson buried inside this entire story, because I think it's genuinely useful beyond just this specific 48-hour window. This outbreak didn't develop in isolation. And understanding the chain connecting it to the broader pattern helps you recognize similar setups in the future. An extreme, prolonged heat wave built up extraordinary heat and moisture across the Mediterranean region over the preceding days. That same heat and moisture then got pulled northward by an approaching upper-level trough and jet stream, transporting the fuel for violent thunderstorm development directly into a region already primed with strong wind shear. That's a genuinely common pattern behind Europe's most significant severe weather outbreaks. Extreme heat building the fuel and an approaching frontal system providing the trigger and the organizing wind shear needed to turn that fuel into large, violent, tornado-producing supercells, rather than just an ordinary round of summer thunderstorms. Recognizing that pattern, extended extreme heat followed by an approaching frontal boundary, is exactly the kind of signal worth paying attention to anytime it develops again, regardless of the specific countries or dates involved. I want to close by being honest about the uncertainty that still exists within even a forecast this detailed and this confident, because that honesty is exactly what responsible severe weather communication looks like. The forecasters issuing this outlook were explicit that genuine uncertainty remains around exactly how intense and how large Friday's mesoscale convective system will actually become as it moves from Germany and Austria into the Czech Republic, with some models hinting at violent wind gust potential that others don't show with the same confidence. That's not a flaw in the forecast. It's an honest representation of how forecasting genuinely works this close to a rapidly evolving, high-impact event, where the broad pattern and overall threat level carry high confidence, while the precise storm-by-storm details continue sharpening right up until the moment these systems actually develop. Here's what I'd tell you to do with everything we've walked through today, regardless of exactly where within this 2-day, multi-country outbreak you happen to live. Take and tomorrow seriously. This isn't a routine summer thunderstorm forecast. It's a high-risk designation for meteorologists who don't reach for that classification lightly. Built on genuinely extreme atmospheric ingredients, extraordinary instability feeding on an already historic heat wave, combined with the kind of wind shear that turns ordinary storms into organized, violent supercells. Make your preparations now, while the sky is still calm, rather than waiting until storms are already visible on the horizon. And if you want to track exactly how this specific outbreak actually verifies over the coming 2 days, stay close to your National Weather Service's official warnings and to dedicated severe weather forecasting services, tracking this exact system in real time, because the specific timing and location of the most dangerous individual storms will keep sharpening right up until they actually develop. This channel will be covering how this outbreak plays out, and what it connects to as we move deeper into a European fall and winter already being shaped by the same record-strength climate event driving so much of this year's global weather. Stay weather aware out there, and I'll see you in the next one.